Good evening, ladies and gentlemen. A very warm welcome to all our distinguished guests, respected engineers, academics, industry professionals, and students joining us from Sri Lanka and abroad. It is my great pleasure to welcome you all to this collaborative webinar organized by the Sri Lanka Association of Institution of Civil Engineers together with MIDAS India. Today's webinar marks the beginning of an exciting learning journey through an exclusive five-part continuing professional development workshop series designed to bridge the gap between structural modeling and practical design. This expert-led series focuses on real-world infrastructure applications using the Eurocodes and provides participants with integrated structural and geotechnical workflows to model, design, and verify engineering projects with confidence. Over the course of this series, participants will explore 5 practical engineering projects using 3 powerful software solutions under the guidance of premier IIT alumni and senior technical experts from MIDAS IT. We are delighted to have each and every one of you with us this evening. Without further ado, let us begin today's program. To officially welcome you all, we now invite a respected leader of the civil engineering profession and a key figure within our academic and professional community, the chairman of SLAICE, engineer Dr. K.P.I.U. Dharmaphala. Engineer Dharmaphala is a civil engineer with over 45 years of experience in civil engineering construction, project management, and contract administration. He currently serves as the chairman of the Sri Lanka Association of the Institution of Civil Engineers and the chief executive officer of Unica Design Engineers and Consultants Private Limited. He has previously served as the president of the Institution of Civil Engineers Sri Lanka and has contributed extensively to national engineering communities and professional bodies, playing a key role in strengthening engineering practices and standards in Sri Lanka. Until he will be joining with us today, I'm going to give the floor over to our country representative of the Institution of Civil Engineers as the Governor of Region 10 of the American Society of Civil Engineers. And it is my honor to invite Engineer Kamal Laksiri to address the gathering. Sir, over to you.
Okay, thank you very much. Good evening to all of you. I think until Engineer Dharmaphala joins, let me attend to the welcome speech. So first of all, big thank to the MIDAS India Research and Development Center officials and the resource person today for arranging this program with the SLAICE. I think you all are aware, SLAICE is the Sri Lanka Association of the IC UK, and we represent all the IC members in the country. So as our CPD programs, we could work with MIDAS India and organize this program. So this is the first program of the, as I learned, 8 numbers webinars included in this series. And today we are going to discuss about the steel design on a building using the MIDAS software. So I hope this will be a great opportunity for our members, especially young engineers, to get familiar with the new software and also in the application, in real practical applications. So considering the delay, I think I will not go into details further. Let's move into the program. So I thank very much again to the officials of the MIDAS R&D Center India for joining with us. And I request all the members to continue to attend in this program. And I learned that there are about 400 members already registered. So it's a very good sign. And this will be a very useful program, I am very sure. So I request all of you to be with us in this program throughout this series. Okay, thank you again and wish you all a successful program. Thank you.
Thank you very much, sir, for sharing your valuable thoughts and words of encouragement. With that, we now move on to the most anticipated session. It is now my pleasure to introduce our resource person for today's technical session, Mr. Mohammad Zulfekhar Ali. Mr. Mohammed is a senior technical support engineer at MIDAS IT India, holding a master's degree in structural engineering with over 6 years of professional experience in structural analysis, design, and finite element analysis. His areas of expertise include structural dynamics, bridge engineering, high rise buildings, and advanced numerical analysis. Throughout his career, he has worked on a wide range of engineering projects, including prestressed concrete and composite bridges, elevated metro stations, machine foundations, high rise reinforced concrete buildings, time history analysis, seismic isolation systems, and bridge load rating. He is proficient in a wide range of industry leading structural engineering software, including MIDAS Suite, ETABS, STAAD Pro, and AutoCAD, and has extensive experience applying international design standards such as Eurocode, ACI, IS, and BS. In addition to his technical expertise, Mr. Ali has conducted numerous technical webinars and continuing professional development workshops on advanced structural design topics, helping engineers translate theory into practical engineering solutions. Ladies and gentlemen, please join me in warmly welcoming Mr. Mohammad Ali. Sir, the session is all yours.
I hope my screen is visible and audio is clear to all the attendees.
Yes, we can hear you very well, and your presentation also visible very well to us.
Okay, thank you so much for the confirmation. Okay, I welcome you all for the webinar on design of steel warehouse using MIDAS Gen NX in collaboration with ICE and SLA. My name is Zulfekhar Ali and I'm working as a senior application engineer at MIDAS IT. So I will just walk you through the design of steel warehouse using the Eurocode standards. So today we are planning to give a demonstration on a steel warehouse as shown in the figure here. And this is a plan view of the structure where we are having a spacing of 9.75 meters. And along the other direction, we have the spacing of 8 meters with some bracings. So before going deep into the practical demonstration on MIDAS GenNX software, uh, I would like to welcome my colleague Srishti Sharma to introduce brief about the MIDAS.
Greetings of the day, everyone. This is Srishti Sharma from MIDAS India. Introducing myself, I am working as a techno-commercial engineer at MIDAS, and I currently look after Southeast Asia region, including Sri Lanka. We have been in Sri Lanka region from past 8 to 9 years. Like our presence has been there since then. So this time we are collaborating with Sri Lanka Association of Institution of Civil Engineers, SLAICE. MIDAS IT was founded in 1989. We started our journey with the commercial release of MIDAS Gen in Korea and gradually expanded our presence globally. MIDAS IT India was established in 2008, and since then, we have been actively supporting engineers, consultants, and organizations across the country. And in 2026, we are the world's leading engineering solution partner. Today, MIDAS has a strong global network with our head office in Korea and branches distributed in multiple regions across the globe. MIDAS has 4 local branch offices in India, Mumbai, Delhi, Chennai, and Kolkata, with a dedicated team of over 75 engineers. We also have the Global Technical Center in India, providing technical support for all the English-speaking countries. Coming to the different products that MIDAS offers. For bridges, we have MIDAS Civil NX and FE NX, and apart from that, we have our in-house BRIM tool, which is MIDAS CIM. In Geotech, we have MIDAS GTS NX, which is the 2D and 3D FEM analysis software. For mechanical, we have MIDAS NFX and MIDAS Mesh-free software. For building and journal structures, we have MIDAS Gen NX, MIDAS Engine, and Design Plus. So as you all know, we have a complete series. So today we will be discussing about MIDAS Gen NX. Coming to the uses of MIDAS Gen NX, Tata Consulting, Sistra, Lombardi, and numerous organizations have been using this software MIDAS Gen NX. These are also some partial user list. We are present in the government sector as well. Research organizations like BARC, NHAI, RTSO, and many PWDs pan-India are using our software solutions for various applications. Coming to the users of MIDAS in Sri Lanka, we have multiple users, and I am sharing the partial list on the screen. Organizations like CSIC, Design and Structural Consortium, STEMS consultants are using our software. And if I talk about government sector in Sri Lanka, Mahawali Authority of Sri Lanka, Road Development Authority, CECB, have lended their trust on us. So many educational organizations like University of Peradeniya and University of Marathwada are also using MIDAS. Here are few applications of usage of MIDAS Gen NX worldwide. You can see Shanghai Center Building, Hanoi Landmark Tower, Pengan International Finance Center Tower, Tapeyton Tower. There are some few more applications. These are some examples from India. Now, we are moving into the technical session, and I'm really happy to introduce a technical speaker, Mr. Zulfekhar Ali. Mr. Ali is a senior technical support engineer at MIDAS IT India with a master's degree in structural engineering and over 6 years of experience in structural design analysis. Throughout his career, he has worked on a worldwide variety of projects, from high-rise buildings in metro stations to bridges, transmission towers, machine foundations, and many other challenging structures. He has delivered several technical webinars and CPT workshops for engineers across different countries, covering advanced topics like push-over analysis, time history analysis, SSI, column shortening, and many more. One thing you'll notice about Mr. Ali is that he has a very practical way of explaining complex engineering concepts. Whether you have already experienced with MIDAS or just getting started, I'm sure that you will take away something valuable from today's session. So without keeping you waited any longer, I would like to invite Mr. Mohammad Zulfekhar Ali to take it from here. Mr. Ali, over to you.
Thank you, Sisti. Just I will share my screen. Okay. So today we will be focusing more upon the steel warehouse structure and its capabilities and how MIDAS Genetics can efficiently handle such type of steel structures and what are the advantages for the structural engineers. Okay. So I would like to explain all the capabilities with the help of a simple steel warehouse structure as shown in the image here. And this is the plan dimensions along the X and Y direction with the bracings. And this is the elevational view. Typical height is 3 meters with a different floor. And the eave height is 1.8 meters for the truss. So now just I will be directly moving to the software. So this is actually the completed model. Just I want to give the brief idea about the GUI of the software. And the first advantage here is like when we are dealing with steel structures. Obviously, when it comes to the foundations, they are RC members. So instead of modeling them separately, we can combine them and see the global effect of the structure. So either it can be isolated foundations or combined foundations or pile foundations based upon the soil flexibility. So we can model all types of foundations along with the superstructure, combining the RC members as well as the steel members, and predict the actual global behavior of the structure. So that is one of the major advantage here. And the ribbon menu is arranged as per the workflow of the project. So whenever we start any project, we start with structure tab where we have the wizards for different types of structures. And then if you want to make any manual modifications, we have node and element based tools. And then we can define the material properties and the section properties. If you're going more deep into the performance evaluation of the structures, then we can also do provide the hinges, inelastic hinges and inelastic material properties. And then simulating different types of boundary conditions. Okay, so it's not always we are going to provide fixed support or pin support, but based upon the soil flexibility uh, of the site, we also use different types of boundary conditions like surface springs or the pile springs. If you're having piles, then you can go to pile springs and force deformation functions. So basically, soil is a non-linear material. So to simulate the real boundary conditions, we go with force deformation functions, which is a multilinear spring. And then we apply all loads that are acting on a structure and perform the analysis and design and report generation. So today we will see how we can quickly model such type of structures and interpret the results and perform the design. I will start with a new project here. So in the structure tab, basically we have the wizards for general structures like beams, columns, frames. So we use frame wizard today to generate the elevation view of one particular frame. So if you see here, this is the global axis of the global x-axis and the global y-axis, and vertical will be the global z-axis. So along the x direction, we have 9.75 meters with let's say two spans. We can add the coordinates along the x direction. And along the vertical elevation, we have 3 meters with three number of repetitions. And then we go to the edit tab and we generate the frame here. And then we can insert these to just you can hit on apply to insert that particular frame. So if there are any modifications, you can just undo and make the modifications here and just hit on apply. And here we will be having truss. So we just remove the top part and here we have complete opening and at base we don't require the beams. So you can simply select the members and just delete. And then now we have the truss configurations at the top of this particular warehouse. So again, you can go to the base structure wizards and you can select the truss. So sometimes it may be arches when particularly dealing with stadiums or airport hangars, airport structures. Mostly arch wizard will be handy. And now we are dealing with the truss wizard. And in trusses, you can select the different configurations here and the bracing patterns truss and you can specify the length and height here. And since it is a symmetrical truss, I just select the symmetric option here. Then we go to the edit tab and we select the verticals and we can also provide different IDs here and the material properties as well as the section properties that we need to use. And if we don't have the materials and section properties, we can directly click on this three dot button, which will take us to the properties dialog box, and we can add these material section properties. So again, we have huge database for the steel cross sections. It may be a box section. You can select the standard code like American standards, British standards, and the Eurocode standards. So you can select the code and you can just select the standard database. So if you have any user-defined cross-section, then you can go to the user option and you can also modify the properties here. So either you can go for database that is readily available or user-defined sections. And we can also provide the offset to the cross sections to simulate the realistic behavior of the structure. Either it can be center top or center bottom. And if there are any additional offsets, we can also provide the additional offset to the sections. And next interesting part that we have is like the consider warping effect. So generally in our curriculum, we come across 6 degrees of freedom, which is 3 translational degrees of freedom and 3 rotational degrees of freedom. And warping effect is considered as the 7 degrees of freedom, which is nothing but the non-uniform torsion. So these non-uniform torsions will come into the picture when you are dealing with steel structures, since these steel cross sections thickness will be very less compared to the RC cross sections. So the members will develop additional warping effects, warping stresses, and the warping moments, which we need to be considered when we are checking the stresses in the members. So to consider that warping effect, we can just check on this option and we can apply. Okay. And we can also go for the value type of cross sections. And sometimes we may come across the cold form sections as well. So we can also define cold form hat type sections, Z purlins, upright sections. And then we can also define the value type of sections. And sometimes we come across the composite sections where our steel members will be embedded into the concrete sections. So we can also simulate such type of sections and perform the design. And sometimes when the load is very high, we need to go for these combined sections. So two I sections or I with channel sections. So we have different combined sections. And when it comes to the steel structures, weight is the major concern. So we need to optimize our designs by considering the tapered sections. So we can define the tapered sections, whatever the cross-sectional shape it may be, we can easily define the tapered sections and we can analyze and optimize the design. And final part is we come across the composite when we are having the slabs, concrete slabs on the steel girder beams. So we can also go with the composite section. So we have a huge database for the section properties definition. And similarly, material properties, you can select the material properties here. So whether you are dealing with steel structure or concrete or steel reinforced concrete, aluminum. So when you are dealing with facades, you may use aluminum and timbers, or you can also go with the user-defined material properties. So user-defined material properties can be isotropic, which is having same material properties in all the direction, or it can be orthotropic with varying material properties in different axes. So now we focus on steel, and we can select the standard code, that is Eurocode, and we can select the material property or the steel grade here. So the properties will be automatically updated as per the Eurocode. And we can just hit on apply so that the material property will be updated here. And then now we can insert these truss by giving the reference point here. So this insert point, you can select this as a reference where you want to place the truss. Okay. And we can click on show number so that one will be this origin point, and then hit on apply to check it. So now our truss has been generated with the wizard. So the advantage of the wizard here is by giving the just nominal inputs, we are trying to generate the structure. So this is how we can utilize the wizards when we are dealing with the general structures. And then we can just translate all the elements along the y-axis. So we can give the distance along the y directions. So if you want to copy for 4 times, we enter 4 at gauge. And we intersect the node and elements and the copy node attributes. And we select all the elements and just hit on apply. So now we have created the number of base along the y direction. And now using the create elements, we just snap the elements wherever we require. And the interesting part here is the software will automatically intersect the node and elements so that we can directly snap from the start point to end point. So if there are any nodes or elements in between, it will automatically intersect at that location. And with the help of this 360-degree view cube, we can rotate the model as per our convenience in the modeling. And then we can just directly snap these nodes. And similarly in the other direction, we can just snap this top of the truss. And similarly, when it comes to the purlins, you can change the section property here and snap the start nodes and the end nodes. So next, basically your braces will be tension only members. Uh, so we can model different types of elements here. So truss elements, which will be taking the axial compression and tension. But if you want to consider the element to take only the tension forces, we can use the tension only elements. And here we can just add the tension only elements. So one more good part we have here is once we have created all the sections for the next project, we can take the reference of our previous project. We can directly import the data from the previous project. And we can start with new ID S4 and just click on OK. So that all the sections from the previous project will be imported in short span of time. So instead of defining the section properties repetitively, you can use this import feature. And you can select the sections for the tension only members. And basically the tension only members will not intersect. So we can just off this option and we can create a brace at this location. So now this will be treated as a single member, which is not intersected at the junction. So this is how we can create different types of elements in the structure. Next comes the boundary conditions. So for initial preliminary analysis, we can just simply go with the fixed suppose or the pin suppose based upon the assumptions made by the engineer for that particular project. And here we have different view directions. So we can see from the positive X direction as well as the Y direction. So using select single, we'll select all the bottom nodes and apply the suppose here. And next we come to the load applications. So here we can define the static load cases. Here we have different types of loads that act on the structure. It may be the self-weight and some live load. We can add it live load, and then we will having the wind load in X direction and wind load in Y direction. So in this way we can add different static load cases, and then we can just start applying the loads. Self-weight, and we can select the load case name and the factor here, gravity direction. Let's say -1. Negative sign indicates it is acting in the downward direction. And we can add this so that the self-weight with z equal to -1 factor will be shown here. And then application of the live loads. So here we can also create a beam. So using create elements, using the beam element type and cross section, intersecting the node and elements. Now we can apply the live loads. So for that, there are two approaches. We can model the plate elements and apply the pressure loads, or without modeling the plate elements for the slabs, we can assign it as a floor loads. So we can define the floor loads here. Let's say a typical floor load, which consists of self-weight as well as the live load. And the in SW we import the conditional floor finishes, and in the live load we consider -2 kilonewton per meter square, and we just add it here. And for wind loads, we can also apply the wind loads by selecting the wind load in X direction, and we can input the final pressure value considering all the force coefficients. So let's say we have -3 kilonewton per meter square, and we can add the wind load cases as well, and we can apply in terms of the floor loads. Now we'll go to the assign floor loads option, and we select the typical floor loads. And so here we are having the regular slab with a like rectangular shape, but sometimes we may come across irregular slabs. So in that case, to distribute the floor loads, we can use this polygon centroid option to apply the floor loads. And we can also copy the floor loads along the Z direction for the 3 meters. And now we can select the nodes that are defining this area. So we'll start from here, 1, 2, 3, 4, and 5. So in this way, the software will apply the floor loads by using the inline theories. And same floor load is copied to the next level. Now, for example, if you're trying to apply the wind loads, so we can select the load type as wind load in X direction. And we can also select the distribution, whether we want to go for one-way or two-way distribution. And we can select the axis as global X direction. And we just don't want to copy these floor loads. And now we'll select the nodes defining the loading area. So we'll select the cross-sectional view. So based upon the tributary area, the software will automatically apply the loads onto the vertical members. So this is one approach of applying the wind loads. And the second approach is using the wind pressure functions. So we have multiple options like area wind pressure, which will be used for the closed structures or the cladding structures, and beam wind pressures for open structures, like let's say transmission towers, where you will be having complete opening, and the wind will be resisted by the exposed surface area of the elements. And the nodal wind pressure, it will be useful when you're not modeling the members which are taking the wind load. Let's say we are having a building, above that we have a water tank or some transmission towers or some electrical towers. So which are not modeling in the global structure, but we want to add the wind load caused by that structural resistance. So that can be simulated with the help of nodal wind pressure. And other one is function wind pressure, where we can provide this load case name, and we can just select the direction in XY plane. So let's say if you're applying the wind load in the Y direction, we can set the angle as 90 degrees. And here we can define the function for the wind load. So here you can define the wind load function, and you can set the final equations. Okay. So if the wind pressure is constant, you can directly input that value, or you can finalize a standard equation or the empirical equation where your wind pressure will be varying along the height. Okay. So we can use different equations or the functions or the numbers, okay, or the square roots tools, and we can create some empirical equations. With the help of that empirical equations, when we just hit on calculate, the software will calculate the wind pressure along the height 0 to height of the structure. And we can use the same function, and we can select the elements on which we need to apply these load. And the element type is frame elements. And you can select that elements using the select by plane. So I want to select in the X and Z plane. And when I snap this particular point, it will select all the elements that are present in the XZ plane. So which will be very easy to apply the loads. So once I hit on apply, the software will calculate the tributary area and apply the loads on the joints. So which makes the work very easy instead of manually calculating the cross section, the tributary areas. So in case of simple structures, it will be easy, but when we go for large span structures, so this feature will be very handy. And similarly, you can also apply the different types of loads. Let's say you're having temperature loads, where the steel members will expand and contract. So we can also apply the element temperature load. So you can give the name as temperature, and you can select the load case type as temperature. So based upon the type of the load case you are selecting here, the software will automatically provide the load factors for the load combinations. So if you go for user defined, then in that case, we need to manually input that load factor from the Eurocode. So we can select the temperature case, and here we can directly select the delta T temperature. Let's say change in temperature is 10 degrees Celsius. So you can select that particular member and you can apply the temperature load. And then static loads. And we can also simulate the moving loads. Moving loads will be useful when there are movement in the gantry girders. So in that case, we can simulate the moving load and the construction stage. If the structure is constructed in different stages, so we can create the construction stages here. So let's say we are having different construction stages for this so that we can simulate the erection structure stage. So let's say we have two groups. In first stage, we will be having the bottom part, and second stage, we will be erecting the trusses. So these we can be done by providing the construction stages. So we have stage one, where your structure group one will be activated, and we have another stage where your second group will be activated. So now if you see the construction stage here, in stage one, your bare frame will be there, and in second stage, we add the trusses. Okay. So in this way, we can simulate the exact construction sequence of the structure using the construction stages. So we can go back to the basics. For buildings also, we will be having this automatic generation. And then we can go to the analysis. So in the analysis, we have different types of analysis like P delta analysis, buckling analysis. So steel structures will be more susceptible to buckling. So we can perform the buckling analysis and we can find the critical load factor for the buckling analysis. And eigenvalue analysis, if you are interested in the frequency of the structure and the mass participation, we can perform the eigenvalue analysis. Rate of hydration, moving load, and settlement analysis. So when your soil flexibility is varying along the length of the structure, we can simulate different types of settlements and we can do the settlement analysis and nonlinear analysis if you want to consider the plastic behavior of the structure. You can also go for the nonlinear analysis. And boundary change assignment. In this, you can provide different support conditions or the spring stiffness for static load cases as well as seismic load cases. So basically, during the seismic analysis, your soil stiffness or the stiffness modulus of elasticity of the soil will be doubled. So in that case, we can consider the different stiffness for the seismic cases as well as the static cases using this boundary change assignment. So you need not to create multiple model files. In a single model file, you can simulate different stiffness as well as the different boundary conditions so that you can see the results in a single model file as well as the stiffness scale factors when you're dealing with RC structures. And then we can just perform the analysis and check the results. Okay. So now I will just open this model where I have applied all the loads as well as the support conditions. So another advantage here is like in the work stream view, you can see all the works we have done till now. So like the moving load analysis and the story data and nodes and what are the different types of elements we have. So we have truss elements, beam elements, as well as the plate elements, which are modeled for the isolated foundations as well as the pile cap. So these foundations are done using the auto mesh option, and the material properties and the section properties and the stiffness scale factors. So let's say you have an existing structure where your one particular beam member is corroded. So you can select that particular member and you can give the element stiffness scale factor. Okay. So you can directly provide the scale factor to that particular element. So which will be very easy and faster. And the thickness and springs. So for isolated foundation, for piles, we have provided the linear springs and then multilinear springs in the lateral direction and the surface springs for the isolated foundations. So in surface springs, we provide the modulus of subgrade reaction provided by the geotechnical engineer in the vertical directions as well as the lateral directions. And these are the different loads that are acting on the structure like sulfate, dead loads, and the live loads, and the roof, as well as the wind loads in different directions. So another interesting part we have here is the imperfection analysis. Okay. So in case of steel structures, we also need to consider the imperfections as per Eurocode 1993. So in structures, we will be having global imperfections as well as the local imperfection. So global imperfection should be considered in the structure analysis along with the local imperfections. Local imperfections can be automatically taken in the steel design, but for global imperfections, first we need to check the criteria given in clause 5.3 that overall applied lateral load is more than 15% of the vertical load in the member. So in that case, your notional horizontal load can be ignored. But if it is not satisfying the criteria, then we need to apply the equivalent horizontal loads onto the structure using these equations. So vertical axial load into the coefficient phi, again, which will be calculating using phi naught, alpha h, and alpha m. So alpha phi is the basic value 1 by 200, and alpha h is the reduction factor, and alpha m is the reduction factor based upon the number of columns. So now, if you go doing it manually, it is a complicated task because we'll be having lot of members, extract the axial forces, and check whether they are satisfying this criteria or not for different load combinations. So instead of doing that complex job manually, once you perform the analysis, you can directly go to the results tables and then you can check the imperfections. Okay. So you can select the load combinations here and you can just click on OK. So the software will automatically calculate the axial forces for that particular load combination and the horizontal force. And it will check the criteria is satisfied or not, whether the axial force is greater than 0.15 times of the axial force. So if it is not satisfying that criteria, then we need to do the imperfection analysis. Imperfection analysis is required here. So if once the imperfection analysis is required, then we need to calculate the equivalent horizontal load. So instead of calculating that equivalent horizontal load manually, we can use the automatic option. So we can go to the imperfection data. So based upon the story data, the software will automatically read the number of columns in that particular direction. So based upon that, it will calculate the coefficients. Or else you can also go with the user defined coefficient values. So you can also just input these user coefficients or let the software allow to calculate that imperfection coefficient. Once the imperfection coefficient is calculated, then we can create the imperfection loads. So we can convert that vertical loads into the equivalent horizontal load. So just we need to select that load cases and the direction, and you can add that imperfection load cases and simply hit on create imperfection. So once you simply hit on create imperfection load, the software will automatically calculate all these nodal loads. So you can see here. So all these nodal loads are calculated based upon the procedures mentioned in the Eurocode 1993. So which makes the job very easy for the imperfection analysis. Now then when it comes to the results, we have the load combinations here. So we can create separate load combinations for the steel design as well as the concrete design for the foundation. So when it comes to the steel design, again we can automatically generate these load combinations. So either you can add new load combinations or replace the existing load combinations as per the Eurocode. And we also introduced 23 national annexes for the Eurocode. So you can use the national annex based upon the region of the project you are dealing so that you need not to adjust the parameters manually. So we have introduced 23 national annex for the Eurocode. And we can just, if you want to consider the imperfection loads, you can also consider the imperfection loads in the load combinations. So this is how we can automatically generate the load combinations for the strength as well as the serviceability case. And for concrete design, we can also automatically generate the load combination. So which will save a lot of time in generating the load combination. And next is checking the reactions. So you can see the reactions in the graphical format. You can see in the values as well as the legend. So this legend will give the summary of the reactions. Okay. So you can see maximum reaction in the structure is 445. The units are kilonewton for the dead load case. So this is how we can easily read the results from the legend, and we can also create our own customized report by just saving this image, dynamic report image. So if there are any modifications in this particular model, the report will be, the image will be dynamically updated. So I can give the name as reactions here so that we can include it in our reports. And when it comes to the stability of the foundations, we can also see the soil pressures, whether there is any uplift or the loss of contact of the foundation. So that we can get it from here. So all the values are negative, it means it is in compression. And we can also check the limit if this 95 kilonewton per meter square is less than the allowable soil bearing capacity or not. So if it is not satisfying the criteria, then you need to increase the size of the foundations. And if there's any positive value, it means there's a tension, and you need to check for the uplift condition. And next, you can see the deformed shape, displacements, behavior, and you can see the deformed shape of the structure, as well as you can animate the deformation of the structure. Then you can see the beam diagrams, the bending moment diagrams, as well as the shear force diagrams. So you have different components here, axial force, shear force in different directions, and the bending moments. And next important part is like the stresses checks. So here you can also see some additional moments. So generally we see these 6 degrees of freedom, like mx is torsion moment, my and mz. So along with that, we have the additional moments that are generated due to the non. So you can see these warping moments as well into the structure. If there are any warping, you can see the warping moments. And similarly, you will be having the stresses as well. So beam stress diagrams. So where you can see the combined stresses, axial and bending. And you can also see the top fiber and bottom fiber stresses. So 1 and 2 are your top fiber stresses, and 3 and 4 are your bottom fiber stresses. So you can dynamically change the units here. If you want to see the stresses in Newton per mm square, you can directly change the unit system. And if you want to see the 7 degree of freedom warping stresses, then you can check the warping stresses here. And next one is in steel structures, we prefer for equivalent von Mises stresses. So in this, we can also check the von Mises stresses as well as the Tresca shear stresses at different parts of the cross section. And next one is we can also apply the moving loads to represent the gantry structure. So we can define the lane on which the gantry structure will be moving. And then we can provide the axial loads for the crane. And then we can create the moving load case. So after running the analysis, you can see the beam diagrams for the moving load case and the legend. So here we can see the moment in terms of kilonewton meter. So the moment is at maximum at element number 303. So for this, we can see the what is the position of that particular gantry girder using the moving load tracer. So at element number 303, at the mid part, we can see the location of the gantry. So this position is creating the maximum moment, and the minimum moment is created when the gantry is at this location. So we can simulate the moving load of the gantry using the influence lines and extract the accurate results. And then once you are done with the design, analysis and the result interpretation, then you can directly perform the design. Okay, so you can do the steel design. The different codes are available here based upon the project region. You can select the code Eurocode, American, British, and then we can go to the modified steel material. Okay. So in modified steel material, one more challenge that we have when we are dealing with the steel structure is like the yield strength of the material. So for different steel grades, the yield strength will be vary based upon the thickness of the plates in the cross section. So let's say for example we have S235 or in the model let's say S355. So for S355 if the thickness is less than 40 yield strength of 355, but if thickness is more than 40 mm then the yield strength will be reduced to 335. So in Gen NX, the software will automatically consider the change of the yield strength based upon the thickness of the materials or the thickness of the sections. So which makes the job easier in the yield strength of the materials. And next is the definition of the frames. So another challenge we face is calculating the effective length factor. So in GenNX, you can select this option, auto calculate effective length factors. So based upon the stiffness of the members that are connected, the software will automatically calculate the effective length factor. And we can provide the live load reduction factors, effective length factors, and the slenderness checks, and modifying the member types and the serviceability parameters. So in steel structures, the major serviceability check is the deflection check for horizontal members as well as the vertical members. So the software will do the deflection checks along with the ultimate limit state checks. So once you define these serviceability parameters, then you can directly do the steel code check. So it will perform the design checks for all the members. So if you're interested only in one particular member, then you can select that one member and you can do the steel code check. And here you can see the members that are failing in red color and passed in the blue color. And you can also go with member type. We can extend these box. And here you can also select the failed members. So we can connect it to the model view and select all the failed members so that we can activate the failed members in the structure. So these are the failed members in the structure so that we can focus on that failed members for the optimization. So let's say we have this member here. The utility ratio of this member is 1.943. So we can go to that property and you can use this change option. And either we can open a MGB file which have a set of sections, or you can select the code and the cross section. And once you hit on search satisfied section, the software will internally check for the all the sections that are available in the database and suggest us the cross section with its utility ratio. So let's say if you are using HEB 550, then the utility ratio will be 0.879. So we can just simply change that cross section. And next we can see the sections that are passing. So at the end you can see the deflection checks. So you can also see the graphical report here. So where you'll be having the slenderness checks, axial bending, and the deflection checks. So in steel structures, there will be a lot of internal calculations like the section classifications and a lot of torsional buckling checks. So just utility ratio itself is not sufficient for the verification. We also need to generate such type of detailed calculation reports for the verification. So here you can find all the load combinations that are used, and here we can also do the design for the roll sections as well as the built-up sections, and these are the properties and the length parameter that are calculated. So you can see the effective length parameters and the classification of the sections, and you can also see the reference clauses, and the section is the plastic section, and similarly top flange and the left bottom flange of the section, and the web classification and applied factors and the slenderness checks and all the equations like calculating the buckling resistance of the compression members as per clause 6.3.1. So you'll be having detailed reference clauses along with the equations that are used for the calculations. So which will be very handy to verify the designs with the help of these detailed calculation reports. So in steel structures, we can optimize the steel members and then we can see the detailed calculation reports in the design. And we can also do the design for the tapered sections. And finally, you can also extract the quantity of the steel used in the project. So here you will be getting the quantity of the steel for a different cross-sectional shape, and you will be getting the weight of that particular section, so that it will make very easy for the estimation of the steel and concrete. Then we have API where you can just connect with the Excel sheets to automate the workflow, or Python Grasshopper for automating the parametric modeling and optimization. Then Design Plus. So basically, in the Design Plus, you can link the model with MIDAS Gen, and you can do the connection designs like bolted connection designs as well as the moment bolt connection designs. So type, you can select it here, connection type, pin plate, end plate, as well as the column splices, and the material properties and the sections and the load combinations. And here you can select the position for the bolt connection, and you can do the design, or you can also provide the checks. And interesting part is, again, you can generate the detailed calculation reports for the bolted connection. So check trying resistance for the webs and trying resistance for the columns. And you can also generate the drawings for the steel bolt connections and create. So you'll be getting such type of template-based drawings. So these connections you can use for flanges as well as the webs. And then we come across the base plates. So base plate design can be done in the software by using different methods like equivalent t-stub method as well as the finite element methods. So you can just input the data and you can import the design forces from the GenNX, and then you can check whether the sections are safe or not for the base plate. And here you can see the detailed results. So you can check bearing stresses, base plate, rib plate, wing plate, as well as the anchor bolts. So if you want to include the pedestals, you can place on the pedestal. It can be rectangular type or a circular type pedestal. And you can just input the data. And in the section 3, you can use the rib plates if required, number of rib plates along the X direction as well as the Y direction. And you can add the wing plates as well. You can increase the height of the wing plates and you can check whether this configuration is suitable for the design or not. So here you can see most of them are okay, and here the rib plate is failing in the DTR. So the reason you can find it in the detailed calculation report so that we can make the modifications according to it. And then you can create the drawings for the base plate, and you can save it in the AutoCAD DXF or DWG format. So similarly, you have moment bolt connections. So basic connection designs can be done using the Design Plus tool along with the detailed calculation reports as well as the drawing generation. And you can also do the foundation design for the members. So you can import the forces. For the RC members as well as the steel members with the help of Design Plus. And yeah, so next one is like when you are having the tapered sections, then we come across the optimization of the tapered sections. So for that, with the help of API, we are developing a tool which is known as PEB Optimizer. So just I will show you a video of that particular tool, how exactly it is going to work. So this tool is developed using the Python and linked to the MIDAS Gen for the optimization. So let's say we have the tapered groups like first splice and second splice and third splice. We can import the data related to the tapered groups along with the load combinations. And for that load combinations, we can optimize by doing some iterative design. So we can import all the data that is required for the design and just run the tool. So it will provide us the optimum size required for the tapered sections. And once it is satisfied, then we can export back the same sections to the global model. So this is how, with the help of API, we can optimize the things by creating some external tools or by linking with some external platforms. So that can be Excels or Grasshopper. So if anyone is using the Grasshopper, then in that case, we can make such type of templates So this is one of the template Grasshopper script which is created for the steel warehouse structure. So if there are any parametric modeling changes, we can make the changes in the script and we can dynamically update the model. So if someone is doing some parametric studies, so creating different models from the scratch, you can make the changes in the Grasshopper and dynamically update into the software. So which will update the models dynamically here. So where you can save a lot of time in the modeling. So you can see here how fast we can make the changes in the models using the perfect bridge between parametric modeling as well as the structural analysis tool. So there are few enhancements that are included for the Eurocode in Gen Annex 2026. So as I mentioned earlier, we have included national annex for 20 countries for the concrete and the steel, so that based upon the regions, like users can perform the load combinations and the design checks immediately by selecting the corresponding country's national annex. So now here the work will be reduced. You need not to adjust the parameters manually one by one for RC as well as the steel design as well as the cold form steel design. So these are the different parameters included for the steel. The partial safety factors are embedded as per the different national annex. So the partial safety factors as well as the load combination factors are now incorporated in the software, so that you need to just select the national annex. So according to that, the parameters and the partial safety factors. So even when you are generating the load combinations for steel, you can select the national annex here so that the load factors will be automatically updated. So which makes the job of structural engineer very easy. And last part, like we can also see the performance of the existing structures, like where the yielding will take place first. So we have a dedicated tab for pushover analysis, where you can do the pushover analysis and you can see the status of yielding as per the Eurocode 8. So where the yielding will take place. So you can select the legend here. So the blue color is in the linear range. So as it goes on increasing the steps, then it will go from the linear to non-linear stage. So once it reaches to the E, it means the failure of that particular member. Okay. So here you can see different steps, 21, 22. So first status of yielding will be take place at this location. So in this way, you can see the performance of the structure by performing the pushover analysis for the steel structures. So we can define the pushover hinges. We can define the pushover hinge properties for the beams and the columns and properties. So where these properties, you can select input method as auto calculations. So once you do that, surface properties, so which can be seen here. You can go to the properties and you can see the properties here. From the design, it will consider the yield properties. So this is how we can also evaluate the existing steel structures. So do we have any questions? Am I audible? Hello.
Yes, yes, you are audible.
Yeah. So any questions from the participants?
Excuse me, sir. Hope I'm audible. There's a few
So if you have any,
questions to sir from the audience. The first question is, can we import Revit file, the AutoCAD file to MIDAS and do the analysis part?
okay, then yeah, just then we'll take up some question and answers. So does GenNX optimize automatically optimize steel sizes to reduce the steel weight while meeting Eurocode requirements with our concern, or should we always check the logs? Okay, so does MIDAS Gen NX automatically optimize steel member sizes to reduce steel weight while meeting the Eurocode requirements with our concern, or should we need to always check the logs and reports and often? Yeah, let me share my screen. So here the software will automatically optimize all the sections by satisfying all the criteria. So whenever you go to the design, you can select any of these member. Let's say I want to do the beam design here. First we can do the steel coat check. So now you can see the utility ratio is 0.223. You can just select the member and you can go to the change, and here you can select the code, and you can just hit on search satisfy section, so that the software will give us a optimize size. Okay, so you can just select that size and you can just update it here. So this is one approach, and once you bring the section close, then you can update these member. And you can just rerun the analysis to check whether the updated section is satisfied or not. Okay. And another option we have here is like the steel optimal design. So in the steel optimal design, here you can initially set all the dimensions as 0 for that particular section, and you can select that particular section, and you can give the number of repetitions here. Let's say if you are going for 3 repetitions, so software will run the analysis, update the section, and then run the analysis and check whether it is safe or not. So it will do the iterative analysis and optimize the sections. And once the optimization is done based upon the weight as well as the ultimate limit state checks, then we can just update all the cross sections at a single go. Can we import the SAP or ETAPS model into GenX without losing data or vice versa? Okay. So right now, like we can import the models from SAP as well as the ETAPS, but we cannot send the model from GenX to ETAPS or SAP completely. But you can send the 3D DXF files. You can send the skeleton model or the geometry of the structure by exporting these AutoCAD DXF file. So here you can see we have different import and export options. So first from SAP, you can import it from here. For ETAPS, we have one plugin where you can import that ETAPS model to GenNX. And you can export the 3D DXF file in the AutoCAD DXF format, and you can import it into the SAP or ETAPS. So major thing is like the modeling part, geometry will be very time consuming. So we can just use this import AutoCAD DXF file so that you can save time in the modeling. Later on, you can just assign the section properties, metal properties, and loads, which will not consume much amount of time. Yeah, those as you're familiar with SAP, you can import or export the AutoCAD DXF files and SAP files. In connection design, can we import the joint details along with its reaction forces directly into design place? Additionally, does the software support combined welded and bolted connection designs? Okay. So, like in design place, we can do the bolt connections, and we can also directly import the joint forces. But if there are any advanced connections, then in that case, we can export the data to the idea statica. So either you can send the complete model, or if you're interested only in one particular joint, you can select that particular joint and you can export the joint details. So here you will be exporting the joint configurations, member design forces to the idea statica, and there you can select whatever the configurations you required. In design place, we can import the forces, but we can only do the basic connection designs. So this is the design plus tool where you can do the connection designs, bolt connections. So either it can be shear connection or girder splice or the column splice connections. And if it is a movement bolt connection, then we can go for these configurations that are available. And in welding, right now we have welded connections for American standards. But if you want to do welded connections as per the Eurocode, then I would suggest to export the data to the Idea Statica. Is there any way to verify software results to make sure that the results are accurate? Okay. Yeah, so already we have done verifications, and with respect to the standard textbook examples, which we can find in the installation folder of the software. So here when you go to the particular installation folder, you can see all the verifications that are done here for boundary nonlinear analysis, buckling analysis. So here we have all the verification examples. Regarding the trial version of the software, Srishti will get in touch with you. Is there any way to include when modeling the soil, including borehole data to model the soil? We can model the solid elements by providing the geotechnical properties of the soil. But for this, we have dedicated geotechnical analysis software, which is MIDAS GTS-NX, where we can do the detailed soil modeling. Okay, so for detailed soil modeling, I would suggest MIDAS GTS-NX, which is a dedicated tool for geotechnical analysis. So where you can model the soil, where your profile is varying based upon the borehole data, and you can provide different material models. But whereas when it comes to still you can model these data soil model, but you have only restricted properties. Either you can go for the linear material properties by using user defined option. You can define the soil properties, or we can define the materials like more column, where you can provide the angle, and you can also sim isotropic, kinematic, and mixed type. And then you can do the nonlinear analysis for such type of materials. But if you want to go for more detailed soil modeling, then I would suggest MIDAS GTS NX. The good part is we have powerful integration with the structure analysis. Is there an option in MIDAS to model tapered haunch section using rolled steel database shapes? Yeah, so like we can create any type of cross section in the MIDAS using the taper section properties. So here you can see the tapered section. So in AutoCAD DXF, you can create such type of cross section. So here you can see this is a normal tapered section. I will just activate two types of sections here. So this is normal tapered section, and another one is like providing the haunch properties also. Either you can go with such T types, or if you don't want to consider this bottom plate, you can ignore that bottom plate and just model the plate. So this is only just to consider the overall stiffness of that particular member. Can we import Revit file or AutoCAD file to MIDAS and do the analysis part only? Okay. Yes, we have flexibility with Revit. You can import the model as well as the export the model from Revit to MIDAS GenNX or GenNX to the Revit. I think I have covered most of the questions from the chat box. Still, if there are any questions, you can just, if I missed your question, you can just type it again or copy paste it again.
Thank you very much, sir, for that insightful and highly informative session. We sincerely appreciate the time, expertise, and design knowledge you have shared with us this evening, and for taking the time to answer all the questions one by one. And as a gesture of our sincere gratitude for an excellent and enriching session, we would now like to present a token of appreciation to our keynote speaker, Mr. Mohammad Zulfekhar Ali.
Good evening, ladies and gentlemen. Am I audible?
Yes.
Yeah. As we come to the end of today's insightful webinar, it's my great pleasure, privilege on behalf of the SLAICE to propose the vote of thanks. First and foremost, I would like to express our sincere gratitude to our distinguished resource person, Mr. Mohammad Zulfekhar Ali, for delivering an outstanding technical presentation on from modeling to design in Eurocodes of steel structures, and your expertise, practical demonstration, and valuable insights into the application of MIDAS software and Eurocodes have greatly enriched our understanding. Thank you for sharing your knowledge and experience with us. Our heartful appreciation also goes to Mr. Naga Ravi Kiran and Director of MIDAS Research and Development Center India Private Limited, Mr. Kaubas and Ms. Samiksha, and the entire MIDAS team for partnering with ICE Sri Lanka in organizing this valuable webinar series. Your commitment to advancing engineering knowledge and professional development is truly commendable. I would also like to thank the IC Sri Lanka country representative, our executive committee members, and everyone who worked behind the scenes to ensure the successful organization and smooth execution of today's session. A special word of appreciation goes to all our participants, professional engineers, academics, researchers, and engineering students from Sri Lanka and abroad. Thank you for your enthusiastic participation, engaging questions, and active involvement. Your presence has made today's event a great success. We hope you found today's session informative and beneficial, and we warmly invite you to join us for the remaining webinars in this series. Finally, thank you once again to everyone who contributed to making today's event a success. We look forward to seeing you at our next session on 11th July 2026, featuring from modeling to design in Eurocodes of 4-story RC buildings. Thank you all for your participation. Have a pleasant evening. Stay safe.